You're going to write out the quadratic actual function itself if you were just given zeros. For example, if I give you zeros at 3 and -4. If I give you zeros at 3 and -4, what would be the terms that created those zeros?
-3 and 4.
Very good. The x minus 3 and x plus 4. To come up with the quadratic model, then you would do what? Foil it. Just the equation. You just FOIL it out. You get x cubed, or x squared minus x minus 12. That's writing it out. Okay. It is very, very simple. We do this with polynomials a lot later on as well, where we can talk about like a 5th degree polynomial with all these possible zeros and do all this stuff. But all you're doing is just, here's the zero, there's the term.
Easy.
We're trying to get.
Let's see if you're paying attention. Good job. Okay. Not scary, right? This is, what's that? So let's do the other one. Let's do it this way. Let's go to what's called vertex form.
What was the other one called?
That we're writing it out from zeros. There's a couple ways we're going to do it. Vertex form. Excuse me. Remember, we had the 3 versions of quadratic. You had your standard form, y equals ax squared plus bx plus c. You've got vertex form, which is basically kind of like a completing square style problem. And then we had the writing it in terms of zeros. That was that a with 2 terms. So let's say you're given a vertex and a point, and you need to figure out the equation. Well, when you're given a vertex at 2, -3, that means that h and k are 2 and -3. So you substitute in, you get y equals a x minus 2 quantity squared minus 3. That's just what it would look like in generic setup. To finish out the model part of it, well, you had to be given a point. You're given a point, 4 and 1. What do you think I'm going to do with the 4 and 1?
X and 1.
Substitute in for x and y, which means you're going to solve for what? A. Yeah, that's all it is. That's all it is, guys. We're going to take the values that they give you, the ordered pair, and I know it's got to be 1 has to equal a times the quantity, 4 minus 2 squared minus 3. So let's see here. What's 4 minus 2?
2.
2. What's 2 squared?
4.
4. So right now we have the equation 1 equals 4a minus 3.
Oh, you have to put the a under the.
Because we're solving for a. Okay? Yes, ma'am. It'll be given to you. It'll be given to you. They'll give you a vertex and a point.
So
8 equals 1.
yeah.
4 minus 2 is.
Seems like a lot of work.
Add 3. And a is?
1. It seems like a lot of work.
But it's very, very easy to do. Yes, ma'am.
So what is A on the graph then?
A is just, remember, the A is going to be, it's kind of like how slope works with it. It tells you how wide it's going to be, how skinny it's going to be,
Does it really
whether it's
matter to
opening
us?
up or down. That's really all it is. I'm sorry, what was that?
Does it really matter to us, or is it just kind of like the point we defined?
Oh, no, the point will be given to you. You'll be given a vertex and a point. I'll show you. So now we're done. We have A, we got all our stuff, so your answer would be y equals 1, and that would be the equation. That's all it is.
That's my good.
Let's do another one like that. Wait, what?
How do you? Oh. There took up a lot of these. Yeah.
Same idea. Here's a vertex and a point, and I want to write it into that vertex form. I want to get it into y equals a x minus h quantity squared plus k. Yes, ma'am.
So when you find a, you just put it back into that.
Yep. That's all it is.
Hold on.
The idea here is that we're going to solve, we set this up to solve for a, and then you just rewrite it a in the equation, and you're done. Yes, sir.
So on a test, we would have got these 2 points.
Yeah. Yeah, you get the vertex and a point. Write the equation. So here again, all it is we know we have to solve for A, so could you just go ahead and do this?
I gotta remember this equation.
Oh, it's the same problem, isn't it?
Yeah.
Oops, I didn't realize I did that. That's funny.
It's the
Is
exact
H
it's
equal
almost
to
the
X?
exact same problem.
Huh.
It's different.
Okay, the 3 and the 1 are changed.
Oh, let's do a different one then.
If it's minus. Oh yeah, if H is minus, if H is
Oh, was it
minus-
negative? All right.
Wait, I got a question.
Yes, ma'am.
If H is like -1, then would it be +1? Since it's like minus.
What's that?
Since it's minus H, and then if it's negative, it would just become positive. Okay.
Yeah, you get A is 1 again.
So can we not do that one?
Like I said, relatively straightforward, not a lot of scariness here. Okay. So let's do the other one.
Erase these points. No, wait, I was. It's
Intercepts. Yes, sir.
Can two parabolas be parallel?
Well, if we're thinking of
No,
time, I would
they
have
just
found
the same
out.
problem.
Sorry. Oh no, you're fine. That was moved on. So.
Try the different way. This is very similar to the one we did a second ago, where I was telling you to give me a. I gave zeros, and then we worked off of it. Well, sometimes you need to know how much that parabola is going to open up, or that to generate that A value to show what direction it's going and things like that. So if I'm looking at this, where I have zeros at -2 and 3, if my zeros are at -2 and 3, that gives me y equals a x plus 2, x minus 3. Bless you.
Isn't this the same as that -2?
And then what do you think I'm going to use with that ordered pair?
Substitute back in.
That's it. Substitute that ordered pair back in, where you have it at -1 and 2. So 2 has to equal a -1 plus 2.
Then what's the time equation?
This?
Yeah.
This is when it's in this form, when it's in the
What
when
is
it's
this
given at
form
0.
called?
Well, that's the intercept form.
Yeah.
Intercept.
That's all it is. Yeah, this is where these P's and Q's are your zeros. So this is intercept form.
Disgusting. Way to go, guys. I was talking to Mikey.
Wow.
Okay.
And just remember that your P and Q here are just the zeros. It's very, very easy to use any one of these models. Okay? It's very easy to use. So let's see here. We get a -1 times -4. A is 1/2. Okay. Right? I hope.
Where'd you get your X? Like,
Where do you get the X? I got the X and Y right here. Comes from the point.
Yeah.
Here we go.
Should it be +1, -1 plus 2?
Yeah, that makes sense because the graph is opening downward.
Okay.
So your final answer would be y equals -1/2 x plus 2 x minus 3. You're done. That's it. Nice. It is very, very easy to do. And what's nice is that you could actually check your work. You may ask, how do I do that? Well, you use your calculator. I'll show you a couple of things here. If I go to my calculator and I'm going to put in what model I just thought it was -1/2 times x plus 2, x minus 3, I think. So I'm going to type in -0.5. I use decimals a lot of times when I'm using my calculator because it's quicker instead of putting in fractions. That's all. I mean, especially if it's an easy one to work with. Then I'll put in x plus 2, x minus 3.
What's the point?
Hmm? The point was -1, 2, I believe.
Okay, thank you.
So if I look at my table, do I have -1 and 2 on the curve?
Yeah.
That means we math correctly.
Two.
Do you guys know how to get to the table?
You press
Second.
Yeah. Second graph.
Negative one, I got
You're gonna want it, trust me, yeah, because I'm gonna show you something really cool here in a minute. That you don't want to do by hand.
I got something different. Oh wait, that's what I did.
Just real fast thing to check. I mean, there's no reason to ever get something like this wrong. Yes, ma'am. Let me see. What does it say? Oh, your settings are a little messed up. That's all. So,
And then you type in what you want.
Yes, correct.
anybody else's table's all sorts of messed up?
What do you?
Go to the second table. And then the point you use for X and Y. So you see if that's negative one and two. Yes, so see if it negative it is. So that's three. Okay. Thanks. You're welcome. What is sign language? Do you know it? Do you know it?
Oh, I see. We need to do the negative, not the white line on the white graph.
Yeah, that's no, this is
Negative symbols work okay. You can't use the minus symbol. Now you're all right.
So that went down one.
Okay.
And then
Yes, ma'am.
isolation.
Wait, that's cute. Cute.
Did that work for everybody? Like I said, really, really, really easy stuff to do. Okay, really easy stuff. So let's look at something that's a little bit more difficult.
I always would do this. I always do this and then I come back to this.
Let's go to standard form that has these 3 points.
Standard form.
Now, standard form is your ax squared plus bx plus c equals y. Okay.
Lots of forms.
What's that?
Lots of forms.
Yeah. So standard form is the more complex way of doing this. What this is going to do is that you've got 3 sets of x's and y's. I can't see that color at all. Okay? Which means you're going to wind up with 3 different equations. What I'm going to do here, take a, negative 1 squared, plus b times negative 1 plus c equals 5. I'm substituting directly into that standard form of the ax squared, bx, and c, knowing what my x's and y's are. Everybody see where I'm going with that?
Yeah.
So what's negative 1 squared? 1. So I have 1a minus 1b plus c is 5. Okay? I'm going to do the exact same thing for the other 2 equations. I'm going to substitute in 0 for x. I get 0a, because obviously 0 squared, plus 0b, when I multiply that in, plus c has to equal 3.
Are you just
I'm substituting these directly into here. I'm doing that, okay? I'm going right into that form. I do that one more time with 3 and 9. 3 squared is 9, so I get 9a plus 3b plus c equals 9. Notice this is giving you a system of equations with 3 variables. Yes. This one's actually very easy to solve because what's c? 3. It's very, very fast to solve this one by hand, by doing substitutions and things like that. But I'm going to show you an easier way.
Oh, you are.
We're going to use what's called a matrix.
Get the matrix.
The matrices. No, not like
Not like
red pill, blue pill thingy.
Aw.
What we're going to use is called a matrix. Matrices is a section that we don't normally spend a lot of time on, if at all, anymore, just because it's, well, your calculator does all of it for you. So what I want to do is kind of walk you guys through how you utilize a calculator to solve systems of equations. All those systems that we did, you know, the 2 by 2s, 3x squared, where you had to do, what do you got? Adding together, subtracting together, linear combinations, all that fun stuff. Any one of those could have been solved with a few buttons on a calculator. So now I'll show you how to use those buttons. Okay? A matrix. Let me take this into a new sheet here. A matrix is a way of organizing data. Basically what we use with a matrix is we use the coefficients we put them in rows and columns. What I want you to think of is rows. How do you row a boat? Can you row a boat horizontally or vertically? Horizontally. So you row your boat and columns hold it up. No?
The row the boat part made
You
sense.
row a boat across.
I would the column.
Those are rows. Columns are what hold things up.
You said
Columns are vertical.
Why would the column
Well,
be
maybe you're
vertical?
painting it.
What?
What I'm going to do is create a 3 by 3 matrix. The 3 by 3 is going to go for just your A, B's, and C's. Use coefficients including positives and negatives. So my first one would be 1, -1, and 1. That would be my first row. I do the same thing with the next one. 0, 0, 1.
How'd you get the one?
Yeah, the one.
If there's nothing in front of it, what's there?
Oh, I thought
Bless you.
oh.
And then it's 9, 3, and 1. What I'm doing here is I'm creating a matrix. Okay? Now, I also want you to think about how you solve an equation. If I want to solve for x, what do I do with a?
Divide by B.
You divide by it. Now, isn't dividing, if I put this as divide by a, isn't that the same thing as multiplying by its inverse?
Yes.
Isn't that the same thing? Remember the -1 power means an inverse? Do you guys remember that?
No.
Well, you do now. So what happens here with matrices, anytime you want to solve for a variable with a matrix, you take the inverse of the matrix in front of it times the solution matrix. Now, what are my solutions that this has to equal? 5, 3, and 9. You agree? So what I do here is I multiply this with an inverse to a column matrix of 5, 3, and 9. All I'm doing here is using all the coefficients. Okay? What takes the longest to do here, guys, is just putting it in buttons. Because the calculator will come up with this answer instantaneously for you. It'll tell you what A, B, and C is. Let me show you how you do this. In your calculator, hit alpha zoom. Alpha zoom. It should look somewhat similar to what I have in there. I think yours might be horizontally written. Bless you. What I want you to do is create a 3 by 3 matrix. You want 3 columns and 3 rows. So in here, you should be able to just move it.
I got mine.
How do you do this?
Oh, I figured it out.
Up and down, left and right on your arrows.
I can't move mine up and down.
Yeah,
Okay.
Oh, there we go.
Okay.
Got it.
So you got 3 by 3, and then you just go back down where it says OK.
Thank you.
And then just go back to
And now what we're going to do is enter in all of the coefficients. When you enter in your coefficients, use the right arrow button. Do not press enter. Okay?
How do we get the?
Did anybody not figure that out?
0,
Did anybody not get to the matrix okay?
Don't hit enter again.
3,
Everybody okay?
Yeah.
So our coefficients were 1, -1, 1. And just keep hitting the right arrow as you're entering them through. Don't go up, down, or don't hit enter or anything like that.
I think we're up to
Oh, that's, I mean, yeah, that's fine, but just don't hit enter when you're inside the matrix, and it'll bump you out. And then 9, 3, 1. Now I know that I need to put an inverse. You guys know where the inverse button is on your calculator?
It's the x.
X to the -1,
Where's that?
right above x squared. Okay?
Thank you.
Haha. Now you need to create another matrix.
Alpha zoom.
3 rows, 1 column.
Alpha zoom.
Alpha zoom, very good.
Wait, where do you get the negative one?
You just hit negative. Goes to the x squared.
There you are. Alpha zoom. Now what's nice about this, let's say you accidentally put 3 columns in 1 row instead of going 3 rows in 1 column, it'll show you what it looks like. It should just be a column, okay? So it should be hit the wrong button. And then our answers were 5, 3, and 9. 5, 3, 9. And now I hit enter. And it gives me 1, -1, and 3. And that stands for
A, B, and C. A equals 1.
This is A, B, and C.
Yeah.
That's crazy.
That means that my equation works out to be 1x squared minus 1b plus 3 is 1. And there's my,
How'd you get the one negative one?
I-
Did you just press enter?
yep, that's it. What the calculator is doing is it's creating the inverse of that original matrix, multiplying it out, and then multiplying it to that column matrix and doing it instantaneously. Matrices are made for solving systems of equations. This was an example that was pretty easy to work with, but yet you could get some really nasty stuff sometimes. It just makes it so fast, so easy to use, okay? Let's try another one with the calculator. There you go. So let's use the ordered pairs of 20, 25, 40, and 30, 60, and 28. Okay?
You just pick a random place that they work.
Well, I know this one works, so that's why I'm just using this. Remember, you're using this in standard form. So you're using the equation y equals ax squared plus bx plus c. Okay? Should be, you know what, I'm going to put the y on the other side.
That's what I did.
All right? So now our matrix inverse to a column. Well, our column is our y values. 25, 30, 28. Our b values, what goes in the middle here, is just the x's. 20, 40, 60. That goes in the c column is always going to be 1. In the first column, then, it's just going to be the second column squared. So 20 squared, I think, is 400.
Oh, you know.
What's 2 squared? Add 2 zeros then.
Oh, you're doing that all.
This real
Okay?
big old,
And it's just a matter of putting it in your calculator.
just big. Alpha zoom.
The downfall of this calculator on the screen is just it's so slow. Okay, so I have a 3 by 3. That's fine. You're going to get a really weird number, and that's okay. 400.
Whoa.
It's taking forever.
I got 13.
I'm done. Well, look at you. I'm taking slow. I read everything. My calculator really knows, so only in color. Not in function. Only in colors. Okay. So you like a negative or something. So negative 0.085 something.
What was the y values again? It was
25, 30.
25, 30, 28. Thanks, guys. Okay. Type it all in, hit enter, and you get decimals. It's fine. That just means your A value has a decimal to it.
13 or 18?
I think it's 13. 13, yeah. If you typed it in, if you didn't get that, if you didn't get these for your A, B's, and C's, you might have written something down wrong, or you might have put them in a different order. Just something very simple, okay? So your A value, you wind up with negative 0.00875 x squared plus 0.775x plus 13 equals y. Why bother? You don't need to. Just use it right when they come out, right as it comes out like that.
Wait, can I see like the first numbers of the
Yeah.
calculator?
400.
No, like, oh, yeah.
So like I said, guys, there's really no reason for us to have to solve a system of equations anymore. This calculator does it. It's fancy schmancy. Yes, sir. I'm not sure.
What was life like?
There's a button on here.
Seriously.
Where's the inverse button?
I know, they're a little
I'm gonna make something like this.
I mean, if they were extra lazy, I think they want to make this. But if you split them too, how do you figure out how to
So that's one thing we're looking at. The last part of today
How does it work? How does it work?
is using the regression.
How do you just enter it?
Bring it up.
I know. That's what I wanted to do.
He knows how it works.
Exactly. I want to know how it goes.
The last bit with the calculator today is something called quadratic regression. Excuse me. Regression. It's another thing that the calculator will be able to do, and it will find a model that fits a specific data set. Throughout the course of the year, we're going to do different data sets, different what's called regression modeling. And as we get into it more and more, you know what? We do this whole unit of this. We'll not do the regression today. And we'll wait till we do the regression unit, the actual model unit at the end. So we'll just stick with what we did today so far. Questions about how the other ones that we did then? I didn't think it was going to be very difficult. I believe this is what I want you to do. Let me double check it.
Yeah.
Until we get the homework.
Give me 1 second. I think I want to see if I want to change any of it.
Probably like the last ones because
Yeah, no, that's fine.
there's no regression ones, right?
No regression. Just want to make sure.
So weird, like,
All right.
the red
Wait, are they all odds? Like
Yes, ma'am. Odds on all of them that we can check them because I want to make sure you guys did it right. They're not difficult to do. Okay?
Get a picture of the year.
I thought it would have been odd.
Same, I would have too. I was supposed to do